Hi, today we are discussing about the electromagnetism. So this electromagnetism is a very important topic in 10th class physics. In this electromagnetism, we will discuss about the relation between the electric field and as well as the magnetic field. So according to Ørsted, he explained that whenever a conductor is carrying an electric current, so it forms a magnetic field around that conductor. Conductor carrying the electric current, it forms the magnetic field around that conductor. So it is explained by Ørsted. But the direction of electromagnetic field is given by Ampere by his right hand rule. So what is Ampere's right hand rule? So when we hold the thing with the right hand like this, with all the curved fingers, so if you hold the thing by the right hand like this, so it is shown in the direction of the electric current, and all these curved fingers are showing the direction of the magnetic field. So if you hold like this is the conductor, and this thumb is stretched in the direction of the electric current, and this all the fold fingers are shown the direction of magnetic field. So this is magnetic field, you can say. Now in this way, when the straight current carrying conductor I, so it forms a radial magnetic field around that conductor. Radial in the sense a circular magnetic field around the conductor, and this radius may be R of the magnetic field. And this magnetic field which forms around the conductor is always be perpendicular to the direction of the electric current. So here these both are perpendicular, but according to Ampere, this magnetic field which forms around that straight current carrying conductor is always be directly proportional to the strength of the current which is flowing in the conductor, and also inversely proportional to the radius of the radial field, you can say, around the conductor. So by clubbing these two, so you can write I by R. So B is equal to, you can write mu naught by 2 pi into I by R, which is also to be called as a Ampere's law. But according to Ampere's law, whichever it may be saying, but Ampere's law you can say. So what is Ampere's law? Whenever a straight current carrying conductor which forms the magnetic field around that conductor, so around this conductor in the circular field, the magnetic field is forming. So that means from here to around the conductor, anywhere the field you can choose as a small element dl, you can say. So therefore the line integral of magnetic field which forms around the magnetic field, so it is always be in tangential path, B, you can say. B into the small element dl is always be equal to mu naught times of the current which is flowing in the conductor. So it is spread from 0 to 2 pi r, from the smallest part to the entire circular path, anyway it can be formed. Therefore from this one, the integral of dl is nothing but mu naught into I. So therefore B into this L, which can be spread from 0 to 2 pi r, is equal to mu naught into I, you can say. Now this B into, so this you can write as a 2 pi r upper limit minus 0 is a lower limit is equal to mu naught into I, you can say. So therefore B into 2 pi r is equal to mu naught into I, where mu naught is what? Permeability of the free space of the magnetic field. So this magnetic field induction you can write as a mu naught by 2 pi into I by r, you can write. This is nothing but Ampere's law. But this magnetic field induction is always can be defined by the formula. So like this one, whenever a magnet is taken, this magnet can consist the two poles, north and south. This magnet, it can be spread its vicinity like this one, the attraction or repulsion of this magnetic field by this bar magnet. It can be spread within this field. How? So the attraction or repulsion may be spread like this. It is into the south pole, and from the north pole it can be goes outside. Within the magnet, the direction of the magnetic field is south to north, but externally it is spread north to south like this one. So it is a direction of the attraction or repulsion on the magnetic substances which can be within the field. These are the imaginary lines, you can say, and these are called the magnetic lines of force. The magnetic lines of force are nothing but the line which can be drawn along the isolated north pole particle, how it can attract within the magnetic field. These are always be closed curves. It always be starts from the north and ends at the south. These are all the closed curve. At every tangent drawn to the line of force which gives the direction of the magnetic field, you can say. This is about the magnetic field. But within this field, whatever the force of attraction or repulsion offered by this bar magnet per unit pole strength is nothing but the magnetic field induction, you can say. Magnetic field induction. Or else, if the magnetic lines of force can be spread within the field like this one, parallel to each other, but they will always be perpendicular to a normal like this. When all the four fingers are showing this one, these are all lines. So if they can be perpendicular to this plane, so these are the lines. So it is a perpendicular to the plane, you can say, and this plane may be, this group of all these magnetic lines of force is nothing but called as a pi. So which is called as a flux, magnetic flux. And this magnetic flux unit is nothing but Weber. And it is Weber, it can be measured. This is the area on which these lines of force are perpendicular. So this magnetic flux per unit area is also called this is nothing but flux by area, you can write. So this is nothing but magnetic flux density. Magnetic flux density, you can say. And this is nothing but, what is the unit of this one? Weber per meter square. You see this one, how these lines of force can be spread in the magnetic field, and these lines of force are when they are going to parallel each other, and the group of these all the lines of force is called nothing but the magnetic flux, and they are calculated per unit area when they are going normal to the surface, any particular surface. It can be calculated, and that can be called as a magnetic flux density or magnetic field induction, you can say. So this magnetic field induction is related with the electric current. And when the electric current is flowing, for example, according to the right hand rule, you can say, whenever an electric current is passing inside this one conductor, for example, this right thumb, you can say, these are all the magnetic lines of force. This is nothing but the direction of the current. And when the current is shown like this one, what happened? It is out of the plane. So when it is shown into the plane means this direction is what? Clockwise direction. So this is out of the paper, this direction is what? Anti-clockwise. So it is anti-clockwise, this is out of the paper, out of plane you can say. Anti-clockwise direction is there, the rotation of the magnetic field. And when it is coming into the paper what happened? The direction is clockwise. So this is shown like this one. You see, it is anti-clockwise direction out of the paper. This is into paper, into the plane, and the direction of the rotation of the coil is nothing but clockwise direction. And this is about the amperes right thumb rule you can say. From this one, this magnetic flux density, whenever if the lines of force are maybe taken as like this one, but if the plane is going to be make some angle from the original direction of the normal, so this is the direction how it bends, theta. Now whenever it bends theta, the component of this one, horizontal component, is called as the A cos theta you can say. This is original area A. The component of this normal is nothing but A cos theta, which is perpendicular to this direction of the magnetic lines of force, which is pi. So from this formula, B is equal to pi by, you can write A cos theta. So therefore pi is equal to what you can write? B A cos theta. So always be, you see that normal is 0 degree. 0 means maximum. Cos 0 is nothing but 1 you can say. Thereby the flux is maximum to the normal you can say. Now but when the theta is 0, theta is 90 degrees. Cos 90 is what? 0. That means this normal is parallel to this lines of force. Thereby what happened? The flux passes through that plane is nothing but always be 0 you can say. So therefore they will be calculated always be the lines of force are perpendicular to the plane you can say. This is about the electromagnetism introduction. The Oersted said that one, whenever the current carrying through a conductor and it forms a magnetic field around that one, the amperes right hand rule is given. What is that one? Whenever a thing is held by the right hand and the direction of the current is in the direction of the conductor held by the right hand, and all these curled fingers are showing the direction of the magnetic field. From that one only we have developed that Ampere's law, and which is to be developed by the Biot-Savart's law. That is later on we can discuss of course, but up to 10th class, so we have to be stick to this magnetic flux and the magnetic flux density, magnetic field induction, and this is about the Ampere's right hand rule and electromagnetism introduction. Thank you.